All right, so moving on to problem number 4. It says you buy a new mountain bike for $500. The value of the bike decreases 25% every year. Write a model giving the mountain's bike value Y in dollars after 2 years. And B, find the value of the bike after 5 years using this model. All right, so again, the key thing that we need to identify here is what equation to use. Okay, so it says you have a new bike for $500 and it loses value 25% each year. And so if it doesn't tell you a frequency, it doesn't tell you, hey, it's compounded continuously, monthly, you're going to use the general decay formula. Y is equal to A, 1 minus R to the T. Okay, so in part A, just is write a model. So what you can do is Y as a function of time. The initial value of the bike is $500. The rate at which it's losing is 25%, so as a decimal, 0.25. And then you can simplify this. This is 500.75 raised to the T. So this is the model of the amount of the bikes, the value of the bike after T years. Okay, so that's it for part A. And then once you have the model, right, for part B, it says find the value of the bike after 5 years. So when T is equal to 5, right, Y of T is equal to question mark. It's just a straight plug-in. Okay, so Y of 5, 500.75 raised to the 5. And the value of the bike, let's see, apparently I did not write the answer down to this problem, so I'm going to use my calculator. 500 times 0.75 raised to the 5th will give you $118. Okay, so after 5 years, right, this bike is not worth that much in terms of resale value. All right, moving on to number 5. It says accounting is losing population at a rate of 0.7% a year. If the population in 2011 is 1 million, what is it expected to be in the year 2018? Assume the city is losing population continuously. Okay, so they already tell you the keyword continuously, right? So you want to use this equation, y is equal to NE. And in this case, we're going to use minus KT, right? Because it's losing population. Okay, so that's how you know whether to use positive or negative. Is if it's growing, you use positive R or positive K. If it's losing value, a percentage, you use negative R or negative K. All right, so if the population in 2011 is 1 million, right, that's the initial, what is the population in 2018? So the initial population, we'll say 1 times 10 to the 6, and it's losing at a rate of 1 million. Sorry, it's losing a rate of 0.7%, which is negative 0.007 as a percentage. I move it 2 decimal places to the left, right? And from 2011 to 2018, right? That's going to be a total of 7 years. That's going to be my time. Okay, so negative 0.007 times 7. And if you multiply this out in your calculator, it looks like your new population in 2018 will be 952,181. Okay, you obviously want to round to the nearest person, right? It doesn't make any sense to have like half a person or a third of a person. Okay, moving on to number 6. It says, in an experiment, a culture of bacteria grew at a rate of 35% per hour. If 1,000 bacteria were present at 10 o'clock, how much was present at 10:45? Assume the bacteria is growing continuously. Okay, so again, we're going to use the y is equal to NE, this time to the positive KT, right? Because it's growing. And so the initial amount of bacteria present at 10 o'clock is 1,000. And the rate at which it's growing is 35% per hour, so 0.35 is my rate. And the time, right, 10:45, 10 o'clock to 10:45, right? This is going to be 45 minutes, but you want to express this as a percentage for your time per hour. So 45 minutes, right, times 1 hour is 60 minutes. Okay, so you want to write this as 45 over 60. If you want to reduce it, you can get 9 over 12, which is 3 over 4. Okay, so 3 over 4 is going to be my time. Okay, so if you punch this in on your calculator, you should get the answer indicated on the worksheet. Okay, so 1,000 to the e raised to the 0.35 times 0.75, and you'll get about 1,300 bacteria at 1045. Okay, so make sure you write down units. So for number 4 is dollars, number 5 was people, and this is